We are back with the second episode in our summer research series. Right now, we're looking at the connection between serotonin, that feel-good hormone, the one we sure miss when there's not enough of it, and its ties to a beta-amyloid peptide that's linked to Alzheimer's disease. Our guest today is Jack Walther. He's a biomedical science student, and he's about 2 semesters away from earning his honors degree. Jack's our guest today on Researchers Under the Scope. I'm your host, Jen Cannell, and this is Researchers Under the Scope. We recorded this episode back in October on the 4th floor of the Health Sciences building at the University of Saskatchewan's College of Medicine. We are checking in with a student who worked in Dr. Darrell Mousseau's psychiatry lab this summer. Jack Walther is studying neuroscience. He's in the final year of his undergraduate honors degree, and here's our conversation. Hello, Jack. Welcome to Researchers Under the Scope.
How's it, Jen? Thanks for having me here. It's great to be here.
What's the best way of describing what you worked on this summer?
Yeah, what we worked on in the lab this summer was trying to determine whether there's a physical interaction between the serotonin transporter and the beta amyloid peptides that are symptomatic of Alzheimer's disease.
So they show up when Alzheimer's disease is present?
Yes, yeah. So it's not necessarily the one and only or be-all, end-all, but what has been found is that patients with Alzheimer's disease do have an accumulation of these beta amyloids in their brain.
So the exact question you said about answering was what?
We wanted to see if there's a physical interaction between the beta amyloid peptides and the serotonin transporter.
How'd you go about figuring that out?
Well, we started off by growing these cells called HEK293 cells. They are human embryonic kidney cells, and what has been found is that they have quite similar characteristics to nervous system cells or neurons. And so we grew those up and then treated them with cross-linking reagents. These are reagents that capture protein-protein interactions of the proteins that are physically interacting. And so we used 2 of them. If we had to give them names, the one is DSS, and that is the cell permeable reagent, compared to BS3, which is a cell impermeable reagent.
It will not go in.
It does not go into the cell. So what that means is that the BS3 looks at the exterior cell surface and the interactions that are going there, and DSS is able to look at the interior of the cell and see what interactions are happening.
Okay, so take me back to when you walked into the lab and realized, okay, this is what we're going to do. These are the methods we're going to use. What happened next?
Well, it started off with a lot of education. Yeah, I needed a lot of guidance. First time being in a research lab like this. And so I'm very grateful for the guidance of Dr. Darrell Mousseau and his 2 lab technicians, Ryan Heistat and Justin Lucan. I went through a whole lot of this is what to do, this is how to do it with them. And once we started growing the cells, it took a couple of weeks to grow the cells because we needed enough plates for all of the different conditions we were testing. There was a control group, a BS3 group, and a DSS group.
Right, the permeables, the impermeables. Okay.
That's right. And then we were also testing the antidepressants.
Ah.
Right. So that then means that we need further groups because we had a control group of that. Then we had tricyclic antidepressants, selective serotonin reuptake inhibitors, and a serotonin and norepinephrine reuptake inhibitor.
Okay. And so you have to make a lot of tiny kidney cells.
That's right. So we needed 12 different groups.
How did you go about growing them?
By incubating them in a lab incubator. It's 37 degrees Celsius with 5% carbon dioxide. And you had to change the media every couple of days. Generally, it's 2 days apart from the weekend. And just by putting them into these plates with the media, it gives them time to grow. There'd be enough cells that you could split them, for example, 1 plate into 3 plates.
Oh, okay. And how did it go?
It was great. We did hit a couple snags here and there. But again, it was nothing we couldn't overcome, especially with the guidance of the lab techs and Dr. Mousseau.
When you say snag, like what were you concerned about?
Well, when we got to the point where we had enough plates to start the experiment, there was still the question of, is the concentration of the cells in these plates sufficient? And so we kind of looked at each other. The lab technician that I was working the closest with was Ryan. And we kind of looked at each other and said, oh, I don't know, you know?
Oh, crap. There's no guidebook for this. I'm not sure.
That's right. And so we weren't very sure if at that point we could go ahead with the experiment, or do we take a step back, give the cells a bit more time to grow, or to split them once again to refresh the media and then just use 12 of the plates of however many we had at that point. So it was kind of a crossroad that we had to determine which way are we going from this.
And I mean, how many days or weeks in were you at this point?
At this point, it was about a week and a half in, coming up to 2 weeks. We were lucky that it wasn't later down the road. But yeah, we definitely needed to decide how are we going to handle this.
What'd you do?
Well, then we looked to the other lab technician, Justin Lucan. He had a lot more experience growing and using the HEK293 cells. So we called him over and he had a look at the cells we had grown. And from him and his perspective, he then said, I know what you guys are thinking and maybe not, but from my experience, you should be okay to go ahead with this. And so we said, okay, you're the man, you know what you're doing. So we went ahead with the cells that we had.
What were the results?
That was a big moment because Dr. Mousseau, he came into the lab and he wanted to make sure that I knew what we had and learn what we were picking up. And so he kind of prompted me with, what do you see? What does this mean? And that was not only teaching me, but I could see the excitement in his face, and it just made kind of the lab buzz a little to be like, this is something. You know, we've got something here, and we're in the right direction. We found that there is actually some kind of physical interaction between these beta amyloids and the serotonin receptor.
Like the permeable ones, the impermeable, what happened there?
Funny enough, it was only the cell permeable condition that we found these results. There was nothing on the cell exterior, as would have been told by the BS3, the impermeable one, but only the DSS group that goes into the cell showed these results.
Huh. And so I know a couple days ago you would have had to come and do the poster presentation. How did showing the world your results go? How are things now?
I mean, it was great. It was also exciting. It's the first time I've had to present research too. But it was great. I think it was pretty well received. And I think it was exciting because a lot of the people that I was showing the research to, they were med students. There were a couple of pharmacy students as well. And so I think for them to see this research coming up and knowing the possible implications it could have in the future, I think that it was valuable, not only to me, but to all of us.
From here, where do you want to take things for yourself? Like, are you going to be applying to be one of those med students at some point? Do you maybe want to get more into the lab? Like, are you at a crossroads?
Yeah, to be honest, my destination is not yet fully concrete. You know, it's still, I am at the crossroads, like you say. I could go left, I could go right, I could go back and over. You know, I don't know yet. I think at this point, I still have to find what I'm most passionate about and pursue that. And so I will be applying to probably multiple programs just to try and determine what, if I got accepted into it, makes me most excited. What makes me think, yes, I'm so glad that happened because that's what I wanted. And it's almost one of those where there's so many options, but you have to wait until it really jumps out at you to know fully.
Did you treat it like a regular job, or did you come in at certain times? Or
Yeah, I definitely treated it as a full-time job. I had the idea of going in 9 to 5. This is what I was doing. And so by doing that, I think it almost felt like it was an internship or I was coming into a new job, because I started off and I had to go through this training and get all this information in. And it was incredible to see how they do it in the lab and how it differs to the knowledge we gain in the classroom.
Yeah. What struck you about that?
Well, knowing the stuff from the classroom and then putting it into effect in the lab, I found was totally different. I look at the classwork and I can know the theory behind it completely, but put me in the lab and I still didn't know what to do. I still needed the guidance of the people that were there and who had the experience. And only once they had shown me and I'd done it a couple of times, it's, creating the habit of the work, and like learning to ride a bicycle. It's daunting once you get onto it, but once you get the pedals going, it makes a lot more sense and you feel way more comfortable.
What are we starting to realize about hormones like serotonin and sort of their relationship with the way that some of these diseases progress?
Yeah, I think serotonin itself plays a part in only a few of the conditions. There's so many daunting conditions that are out there. And so when we looked at the serotonin transporter and Alzheimer's, I think what is important to know is that it's not just Alzheimer's. Serotonin is also linked to depression. Depression increases the chance of Alzheimer's. So there's a link there too. And so that really opens the door, and it makes people realize that this is not just Alzheimer's that we're looking at. There's further implications. And so we know that a deficit in the serotonin system is implicated in both Alzheimer's and depression. And we know from previous research in Dr. Mousseau's lab, they found that selective serotonin reuptake inhibitors themselves, the one class of antidepressants, they lead to an intracellular accumulation of the beta amyloids in a worm model of C. elegans.
Oh.
And so now that then brings the question of, yes, there's this interaction, but now what is specific about the SSRIs? How can we now go forward with this research, with the results that we found? And again, we keep bringing up crossroads because they keep showing up, but now it opens the door of, we can look into the mechanism. We can look into, if we use human brain sample, are we finding the same results? Then we can look at the SSRIs and how is that interaction different to the other antidepressants. So I think it's pretty exciting that these results have opened so many doors, and knowing the implications specifically with depression and how prevalent that is in society, this is exciting results. This is exciting news because we're getting somewhere. It's a step in a very big but very exciting direction.
What is coming next for you? What would you like to do?
I want to bring some good into this world. I want people to do well, to feel good. And I think for me, I would like to focus on people that struggle to help themselves, whether that's neurodegenerative or it's people that are just stuck in place and don't know what to do. I feel like growing up, I played a role like that to a lot of people in my life, where I was a listening ear and a shoulder to cry on. And I think by using that experience of me growing up and helping people, if I can now use that in terms of a career, again, whichever way that takes me, that's when I'll be happy with what I've accomplished.
Well, we're really happy that you made time for us here on Researchers Under the Scope, so thank you, Jack.
No, thank you. It's really great to be here.
I have a feeling that dream probably is going to come true in a whole bunch of different ways.
Thank you very much.
Jack Walther's in the final year of his undergraduate honors degree looking at neuroscience. He spent his summer looking at beta amyloid peptides and the changes they create in serotonin receptors. His supervisor was Dr. Darrell Mousseau, and I'll put a link to this lab in our show notes. Researchers Under the Scope is a presentation of the Office of the Vice Dean of Research at the University of Saskatchewan's College of Medicine. We record and produce this podcast on Treaty 6 territory, and we pay our respect to the First Nations and Métis ancestors of this place. We reaffirm our relationship with one another, and this is the part where I thank you for listening to the show and for being a part of science. I'm Jen Cannell. I'm your host. Thank you for sharing your ears with us here on Researchers Under the Scope.